My name is Loyc Vanderkluysen, and I'm a postdoctoral researcher here at ASU. So my role in this project is to study the LUSI mud volcano, which is a mud volcano that appeared in the eastern part of the island of Java in Indonesia. It's erupting in a unsteady fashion. It has an eruption that sends fountains of hot mud about 15 meters in the air every 2 minutes or so. And these eruptions are typically caused by the bursting of large bubbles, bigger than the size of your average or even a tall basketball player. We're using remote sensing techniques to measure the gas composition. One of the instruments we use that is pictured behind me is an open path Fourier transform infrared spectrometer. So when those bubbles burst, they release a certain amount of gases such as water vapor, carbon dioxide, carbon monoxide, and with the open path FTIR, what we're trying to determine is the composition of the gases that are bursting in those bubbles. Understanding the composition of the gases allow us to maybe say something about the plumbing or the origin of the gases at depth. One other tool that we use is a thermal video camera. We can see things a lot better with thermal video cameras in particular because the mud is hot. LUSI presents some challenges as a scientist. The eruption temperature is about the same as boiling temperature, so it's difficult to get access close to the vent because it's very hot to start with, but also because of the water content, it's really easy to sink. It's liquid, but at the same time, we couldn't even take a boat there because it's viscous enough that a boat wouldn't get stuck. So to try to mitigate the effects of the mud being erupted at LUSI, the company that handles the geotechnical aspects on the site has been trying to scoop up the mud, and to do that, they use diggers. But for the diggers to be able to maneuver on the mud, they place the diggers on big barrels so that they can float. So the diggers use their arm not only to dig mud, but also to navigate across those ponds of mixed water and mud. Every once in a while, they lose one and they sink. The time that the digger sank, the operator had to be rescued. So the first time I saw LUSI, the first thing that struck me was really the scale of it. Because as you drive up to LUSI, the first thing you see is the levees that they have built to contain the mud flows. And the levees at the time were 11 meters high, and they are now building them to be 12 meters high, which is about over 40 feet at least. And it gave me also a certain feeling of worry about the proximity between the city and this important communication line on Java. So we're now 5.5 years into the eruption. 40,000 people have had to be displaced because of this eruption, which fills about 4 city blocks. And 10,000 houses have been destroyed. A few casualties have been reported. And this eruption is not stopping. It's slowing down, but it's not stopping. So we're really interested in the hazard aspect of this study. In particular, try to determine what hopes there are for the future and what can be done to mitigate the effect of LUSI.